Hello, how to solve this exponential problem? We have 2 to the power of 3 to the power of 4 to the power of x, and this equals 512. So we are solving for the value of x that will satisfy this equation. Now, this is a cascaded exponential problem. So what we are going to do is we need to express this in exponential form. So we have 512, and 512 is the same as 2 to the power of 9, because if you have 2 times 2 times 2 times 2 times 2 times 2 times 2, this is 1, 2, 3, 4, 5, 6, 7 times 2 times 2. This is 2 into 9 places, so if you multiply this out, you should have 512. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64, 64 times 2, 128, 128 times 2, 256, 256 times 2, this is 512. So that means you can simply express this as we have 2 to the power of 3 to the power of 4 to the power of x equals this 512 here, we can express it as 2 to the power of 9. Now, the essence of doing it this way is that we want the two bases here, the base here, and the base here to be the same. Now, when the two bases are the same, you can compare the exponent. For instance, if you have a to the power of b equals a to the power of c. Now, since the base here and the base here are the same, that means you have b equals c. So that is the same approach that we have applied here. Since the two bases are the same, we compare the exponent. So that means this 3 power 4 power x equals 9. So let's copy that out. We are simply going to have, this is 3 to the power of 4 to the power of x, and this equals 9. Now, this forms another cascaded exponential problem, and we need to also express this in its exponential form. Remember, 9 is a perfect square, which is 3 times 3, and this is the same thing as raising 3 to the power of 2. So let's do that here. We are going to have 3 to the power of 4 to the power of x, and this equals, we are going to replace this 9 here with this 3 to the power of 2. So what we are going to do is to go back to the same identity. Remember, we have a power c equals a power d, that means c equals d. So the whole idea here is just to ensure that the two bases are the same. So the base here is 3 and the base here is 3. So what we are going to do is to compare these exponents, equate them. That means we are going to have 4 to the power of x, and this equals 2. So at this point, we can solve for x. Now, we can solve for x making use of log. So we have log of 4 power x equals log 2. Now, according to this logarithm property, this one method of solving it, I'm going to show you 2 different methods of solving this. Now, if you have log a to the power of b, this equals b times log a. So this x here will come behind the log. What you are going to have is, this is x log of 4 equals log of 2. Now, log of 4, we can express it as, we can have x times log of 4 is the same thing as log of 2 times 2. And this equals log of 2. Now, if you have log a times b, this equals log a plus log b. So what we are going to do is apply this logarithm property here. That means we are going to have x, this x here will multiply. This is log 2 plus this is our a, this is b. We have log 2 again, and this equals log 2. So the next thing we are going to do is we can divide each part of this equation by what we have here. So we have this divided by log 2 plus log 2, and this divided by log 2 plus log 2. So this cancels this. Now, what we are having is x. So we have x equals log 2 divided by log 2 plus log 2 is the same thing as 2 log 2. Remember, the equation of log 2 here is 1. The equation of log 2 here is 1. So 1 plus 1, that is 2 log 2. So log 2 cancels log 2. So what we are having here is that the equation of log 2 here is 1. This is 1 over 2. That is our value of x. Now, this is one method of solving it. The second method of solving this particular problem, look at it here at this point. If you don't want to make use of log, this can be method 2. If you don't want to make use of log, so what you can do is you copy out 4 power x equals 2. 4 here is a perfect square. You can express it as 2 to the power of 2. You have 2 to the power of 2 onto the power of x equals 2. So at this particular point, you can apply the index log. You have a power n or to the power of n equals a power n times n. So what you are going to do is you multiply this particular exponent. You have 2 to the power of this is 2x equals 2. Now, the bases are the same. This 2 is raised to the power of 1. Remember, 2 to the power of 1 is 2. So the next thing we are going to do is, since the bases are the same, we compare the exponent like what we have been doing. So we are going to have 2x equals 1. And from here, you can solve for x. We divide this by 2. We divide this by 2. 2 eliminate 2. You have x equals 1 over 2. Now, this corresponds to what we also had here using the log. So any of the methods here is absolutely very fine. Now, the next step we are going to take will be for us to insert that value back into this particular equation, and let's check if it's going to satisfy the equation. So we have x equals 1 over 2. So let's recopy the problem. We have 2 to the power of 3 to the power of 4 to the power of x equals 5, 1, 2. So let's substitute this value for x. We are going to have 2 to the power of 3 to the power of 4 to the power of 1 over 2 equals 5, 1, 2. Now, when you are having a cascaded exponential problem like this, you start with the topmost exponent. So we have to find the value of 4 power 1 over 2. We have 4 power 1 over 2. So if you simplify this, 4 power 1 over 2 is the same thing as saying square root of 4, which is 2. So this 1 over 2 is the same thing as saying square root, so this is 2. So this 4 power 1 over 2, we can replace it with 2. Now, what we are going to do next is to simply have this as 2 to the power of 3. Now 4 power 1 over 2 is the same thing as 2. We have 2, and this equals 5, 1, 2. So we need to find the value of 3 to the power of 2. 3 to the power of 2 equals 9. That's 3 times 3. So we replace this with that value that is 9. So we need to find 2 to the power of 9, which equals 5, 1, 2. So for you to find the value of 2 power 9, you go back to what I did earlier on. Remember? Look at it here. You have 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64, 64 times 2, 1, 2, 8 times 2, 2, 5, 6 times 2. This is 5, 1, 2. So ladies and gentlemen, our answer has proven to be correct. So that is it. Don't forget to subscribe and share this video. Thank you and goodbye.